Welcome to section 6.3. We're dealing with function operations and some compositions. And this is a mix of a lesson that you kind of did in 2A with a little bit of new stuff. And so I'm going to walk you through this. You'll notice it's pretty big so that we have enough room to write, and I will kind of maneuver around as we go. But I want to start with the is about part of our frame. The point of this lesson is to perform, let's make that a neat, perform basic operations that means add, subtract, multiply, or divide, and to perform composites. And the composite part, I'm going to write it right underneath, the composite part is the part that's new. Okay? So we're performing basic operations, addition, subtraction, multiplication, and division of functions. And then we're also going to perform some things that we call composites. And I'm going to try and walk you through as nicely as I can on that one. When you're dealing with function operations, they're also going to ask you something about the domain. And if we remember from part A, the domain is all of the possible x values. Okay, we call them x values. You also talked about inputs. You talked about independent variables. Those were all words that we used in part A. Okay, so here's what we're going to do. In the first box, we're going to ask you to add them together. We give you a function where we say that in order to find h of x, you take f and you add it to g. Okay, so I'm going to find this h of x by taking whatever f of x was, which was 5x, and I'm going to add it to whatever g was, which is 2x plus 6. Now, as I look at this, I can combine some like terms. So 5x plus 2x is 7x, and then I have this plus 6 at the end. So here's my answer for h of x. Now, they're also going to ask you about the domain, and the question is, what type of numbers can you put in and still get an answer? In order to do domain, what things you want to look for are, can you put in a positive number? Well, could I put a positive number into 7 times x plus 6 and still get an answer? Yes. Could you put in a negative number? If I did 7 times the negative number and I added 6, would you still get a number in your calculator? The answer is yes. And also want to check 0. Could I put 0 in here, 7 times 0 plus 6, and still get a number? Since the answer is yes to both a positive, a negative, and 0, then my domain is all real numbers. Now, in math, we do shorthand this a little bit, and the way you'll see it, it's a double bar with an R. And this means all real numbers. And so from now on, you're going to see me use that as my description for all reals. Okay? In number 2, we're going to ask you to do the same thing. Only in this case, I'm giving you 2 separate equations, and we're going to ask you to subtract them. So to find h of x, I'm going to take this f, which is 4x to the 1/2, and I'm going to ask you to subtract the g, which is negative 9x to the 1/2. While subtracting a negative, we know, is making a positive. And these are like terms because they have the same variable and the same exponent. So I'm asking you to add 4 of something plus 9 of something is 13 of those somethings of x to the 1/2. Now, what I want to talk about for domain in this case, and we might actually write this a little bit different, so I'm going to leave it out there. A 1/2 power is the same thing as a square root. So I could write this as 13 times the square root of x. Now, if you left it here, I would give you the points. The higher we go in mathematics, though, the more we want you to get used to the idea that instead of saying a 1/2 power, we say the square root. And the reason I want to look at the square root is, in fact, I think it's easier to look at domain in terms of a square root. When we think about square root, the only numbers we can't square root and get a real answer, we can't square root negatives. So if I can have positives and I can have 0, because I can square root 0, but I can't square root negatives, then we're looking for the positive numbers and 0. So my domain is all reals greater than or equal to 0. And again, I can square root 0, I just can't square root a negative. Okay, you could also, if you wanted, write this out and say positive real numbers. But you'd also have to say and 0, because 0 is neither positive nor negative. Okay, so this is kind of getting us started with the easier ones, addition and subtraction. What we're going to do next is multiplication and division. So let me slide down a moment. Okay, take a look at the multiplication one. We want you to multiply f and g together. So I'm going to look at this and say, okay, well, h of x is 6x times 7x to the 1/2 power. This is a question we did actually pretty similar to one we did earlier when we talked about exponents, actually in chapter 5. But we want to look at this and we multiply the numbers. So 6 times 7 is 42. And I want you to remember we add the exponents. Maybe. All right, if I'm going to add in the exponents, this is an x to the first. So our question is, what's 1 plus 1/2? I'm going to write this right above. What's 1 plus 1/2? Now I know it's 1 1/2. But we don't want to leave an exponent with a mixed fraction. 1 1/2 is the same thing as 3/2, and you can put that in your calculator if you need and hit math fraction. So this is 42x to the 3/2. Now, in order to look at domain, we again need to look at the root. And this is a 2, so it's a square root. So this is a square root function. We're cubing it also, but we're more concerned about the root because that's going to limit our domain. Because, again, I can't square root a negative number, my domain is like the one above, where I say all reals greater than or equal to 0. One thing to keep in mind, you will notice it's a square root. This domain stays for all even roots. So it could be a square root, it could be a 4th root, it could be a 6th root. When the denominator of your exponent is even, then your domain will be all reals greater than or equal to 0. Okay, so keep that in mind. Last one in this section is division. So in order to find h, I need to divide f and g. So I have 3x over x to the 1/5. Now let's talk about how this works. When we multiplied, we added our exponents. When we divided, we'll subtract our exponents. Okay, so I'm asking what's 1 minus 1/5. And if you use your calculator to help, you get 4/5. The 3 is not dividing by anything, or there's really a 1 there, but 3 divided by 1 is still 3. And then I have this x to the 4/5. Now, as I look at this, this is a 5th root. I'm having a hard time with my pen today, I apologize. Let's just use the number instead. A 5th root. And because it's a 5th root, I can take the 5th root of positive numbers, of negative numbers, and of 0. So because I can take the fifth root of every type of number, I say my domain then is all reals. And one thing to keep in mind, anytime you have an odd root, your domain will be all reals. Okay? So these are little tricks of the trade to kind of get together there and see. But again, the even roots and the odd roots are something that I would kind of keep in mind, or at least memorize or start to figure out, because we want you to be able to look at anything and tell me what is its domain. Okay? Now I'm going to get rid of this and I'm going to go in the middle column and I'm going to go up to the top. And we're going to start this idea of composites. And actually I can leave it there. And what we're going to do is we're going to input the value of one function into the other function. Okay? Now it's way easier to do in terms of numbers, so I want to start there so you get the idea. Okay? Now whenever you have this, you want to start on the inside, and they're asking you to take whatever f of 5 is. We're going to evaluate when you plug a 5 into f, and whatever we get there, we're going to plug it into g. So this is really a two-part question. So below this, I'm going to start with what f of 5 is. Well, I look at my f function, and what it means is plug in a 5 for x. So I'm going to say, what is 3 times 5 minus 8? Well, 3 times 5 is 15, and 15 minus 8 is 7. Now this 7 is what I'm going to put in then to my g function. So I'm now going to look at g of 7, and I'm going to say, well, 2 times 7 squared, well, 7 squared is 49, so 2 times 49 is 98. And 98 is our final answer. And so you're going to take one value, once you get the first value, and you're going to plug it into the outside function. Now I'm going to skip around a little bit so that you have space and you can try a few on your own if you need. But let's do C. I'm going to take f of 10. So I'm going to put my work below it, and what that says is put 10 into the f function. So that means 3 times 10 minus 8. Well, 3 times 10 is 30, and 30 minus 8 is 22. So the 22 is now going to be plugged back into the f function again because f is on the outside. So if I do f again, now with my 22, I'm going to say 3 times 22 minus 8. Well, 3 times 22 is 66, and 66 minus 8 is 58. So 58 is my answer. Okay, so let's try some a little bit more difficult. Let's do, in the next box, let's look at, boy, I don't know, let's look at A. Okay, they are asking you to start with g of 2. So I'm going to take g of 2, and I'm going to find that first. So 4 times 2, I go to my g function, plus 2. 4 times 2 is 8. 8 plus 2 is 10. And I'm going to take that 10 now, and I'm going to plug it into the f. So f of 10 is 5 times 10 squared plus 10. Well, 10 squared is 100. 100 times 5 is 500, and 500 plus 10 is 510. Okay, let's go the other direction. Let's do C. I'm going to start with f of 4. All right, so in 4, I say 5 times 4 squared plus 10. Again, I'm pretty sure you know at this point in time you can plug it right in your calculator. 4 squared is 16. And then you do 16 times 5, which is 80. And 80 plus 10 is 90. Ooh, let's make that look like a 90. So my 90 is going to be what gets plugged into G. So G of 90. So I take 4 times 90 plus 2. Well, 4 times 90 is 360. Plus 2 is 362. And there you go. The number composites are really, really nice. You plug one number into a function, whatever number you get, you plug into the other function. So the number ones are nice. It's the ones that you're looking at that we're going to do next that are a little bit more difficult. Now, I know I have this box in here. I actually want you to flip it over, and we're going to do the back side just because I want you to have sufficient enough space to go through these two questions because it is going to take us a little bit. So if you can flip your page over, and I'm going to go get a blank screen here a minute so that we can go through it. Okay, so let's walk through. If you look, they give us f of x equals 4x to the negative 1. And they give us that g of x is 5x minus 2. Okay? We're going to do the composites now where they don't care what number you get out. They want to know what equation it is. So I'm going to start in A, where they ask you for f of g of x. Okay. All right, here we go. Like we did before, we took whatever our answer was for g of x, and we plugged it into f. The only difference here is now we have to take an entire equation and plug it into another equation. So I'm going to take my g, and I'm going to write it here a second, as 5x minus 2. And you'll notice I left some space on either side. And I want to put the f part around it. And what we did is we replaced the x with whatever our answer was from the first step. Well, we know our answer for g is 5x minus 2. So I'm going to put parentheses around that. Instead of the x, I'm going to leave the parentheses. So it's 4 times this to the negative 1. Now another way I've done this before, it looks the same, but I want to maybe word it a little bit differently, is that maybe you want to start with the f. And if I do that, let me show you what that looks like a minute. Keep yours there, but here's what it does if you start with the f. If I start with the f, anywhere I see an x, I'm going to put a parentheses to the negative 1. Now, what function is inside of f? Well, g is inside of f, so this 5x minus 2 goes in the inside. And sometimes that's a little easier to see. Now, you'll notice we got to simplify this. This negative exponent is tied to the parentheses. And negative exponents take a whole number and make it a fraction. And it basically moves it to a denominator. So the 4 still stays on the top. Then the 5x minus 2 goes on the bottom. And now I don't have any exponent anymore because to the first power is exactly the same thing as what you get. So this is our composite for f of g of x. In this, they also ask you for the domain. The domain of fractions is basically all reals except where the denominator is 0, because you cannot divide anything by 0. You get something that's undefined. So what we're going to do is we're going to set our denominator equal to 0. We're going to say 5x minus 2 equals 0, and we're going to solve. And we get that x is 2 over 5. What that means is I can use any number I want except for 2 over 5 because I'll get an undefined fraction. So my domain, the way we say that is all reals except or not equal to 2 over 5. And again, make a little note if you need that whenever you're going through, when it's a fraction, you're going to have to set your denominator equal to 0. Okay? Now I'm going to do part B because we're dealing with the same fraction. I'm going to put part B here next to it. And then we'll draw a line kind of halfway through our page and do the other one on the bottom. If I look at this, they now want you to go backwards. What is g of f of x? And I'm going to take it the second way in wording. I'm going to start with a g, and where I see the x, I'm going to put parentheses. Excuse me. Inside of g is the function f. F is on the inside, so 4x to the negative 1 is also on the inside. Now it's the way that we write this that's going to be our biggest thing. Okay, I'm going to leave this 5, and then I'm going to multiply by. Now this negative 1 is only tied to the x, so that means the 4 stays on top, the x goes on bottom, minus 2. And I want to simplify this still because 5 is the same thing as 5 over 1. So when I multiply fractions, I multiply the numerator to get 20 over x minus 2. And so this is g of f of x. Now, when we talk about domain, we said anytime there's a fraction, you set your denominator equal to 0. Well, my denominator in this case is only x. So my place that I can't have is when x equals 0. So my domain is all reals except 0. Because at 0, if I put a 0 in my denominator, I get an undefined fraction. So there's my domain. Okay, now draw a line underneath that, and we're going to do the second one there, and we'll practice more as a warm-up in class. But if you draw a line, we want to do the second one that's on the worksheet. Because I don't need to move mine if I get rid of it, sorry. Take a look. The second one that they give you, f of x is 6x to the negative 2. It's not negative 1 anymore, so that 2 is going to have to play in there somehow. And my g of x is 4x plus 5. Okay, and we're going to do both composites, f of g of x and g of f of x. So let's start with A. Let's do f of g of x. That means start with f and leave a space, leave parentheses where the x is. So 6 parentheses negative 2. What function goes inside of f? We know that g is inside of f, so we put 4x plus 5 inside our parentheses. Now, let's talk about exponents. Similar idea to the last one. This is tied to only the parentheses, which means that's going to go in the bottom because of the negative exponent. Now, the problem is the 2 then has to stay. So we have a 6 in the numerator, and we have 4x plus 5 squared in my denominator. This is my composite function. I don't want you to try and square those because you'd have to FOIL, and in the long run it's going to be way worse. But I want the general idea. A negative exponent moves a quantity to the denominator. If I look at domain again, we again set our denominator equal to 0. I only have to worry about this 4x plus 5 Because if this is 0 and I square it, I still get 0. So I'm going to solve. I'm going to divide this by 4. X equals -5/4. Therefore, my domain is all reals except -5/4. Because again, it all comes back to that denominator. Last one, in part B, I want to do g of f of x, which means I start with g. So I start with the 4, put a parentheses where the x is, plus 5. And inside of g goes f. So f goes inside of the parentheses. And we again want to talk about how to write this. The 4 stays outside. The x is the only thing that's getting that -2 power. So it's 6 over x squared plus 5. And if I do this 4 over 1, I know that 4 times 6 is 24 over x squared plus 5. Here's my composite. Again, to find domain, we set our denominator equal to 0. And I'm going to go the same way I did before. If I set just this single thing to 0, then if I square it, that should also be 0. So I don't really care about the squared, which means my domain is all reals except 0. Now this is a pretty tough idea, this idea of a composite, and I do understand that. We are going to make sure that we practice more in class, especially with dealing with exponent rules and how do we move things around. But I hope you got the general idea down. Please make sure you've asked questions in class if you're still looking at some of these and going, I kind of get it, but I'm not quite sure. Okay? So that's the end of video 6.3. Thank you for watching.